Good morning. Today we are going to discuss about the concept of counting. So in today's class we are going to discuss about basic counting principles such as product rule, sum rule, subtraction rule, division rule, and some examples we are going to discuss in today's class. So first we will discuss about product rule. So what is a product rule? So suppose that a procedure can be broken into a sequence of two tasks. If there are n1 ways to do the first task and n2 ways to do the second task, then there will be n1 into n2 ways to do the procedure. So this rule is called as product rule. So that means here some procedure which has to be executed, that will be split into two tasks. One task can be done in n1 ways and another task can be done in n2 ways. Then there will be total n1 into n2 number of ways to execute the procedure. So this rule is called as product rule. Here an example are there. How many bit strings of length 7 are there? Bit string means length 7. For example, first bit, second, third, fourth, fifth, sixth, seventh. So we have to find bit string of length 7. So bit means we can take either 0 or 1. So first bit can be either 0 or 1. So for first bit there are two ways. Similarly for second bit there are two ways. Third bit can be 0 or 1, two ways. Fourth, 2, 5, 6, 7. So for each bit in the given bit string there will be two possibilities, either 0 or 1. So totally there are 2 power 7 possible bit strings of length 7. So this is one of the examples for product rule. One more example. How many different license plates can be made if each plate contains a sequence of 3 uppercase letters followed by 3 digits? So this is an example for product rule. Here what we have to do? We have to make different license plates. So each license plate will contain a sequence of 3 uppercase alphabets followed by 3 digits. So in each license plate, first we will contain one letter, another letter, alphabet. So 3 uppercase alphabets followed by 3 digits. Digit, digit, digit. So each license plate contains 3 alphabets followed by 3 digits. We have to find how many possibilities are there. If you see the first bit, it may be uppercase alphabet. How many alphabets are there in English? 26. So for first bit there are 26 possibilities. For second bit also there are 26. For third alphabet there are 26 options. So 3 alphabets followed by 3 digits. So first digit can be in between 0 to 9. So in between 0 to 9 we have 10 possibilities. So first digit there are 10 possibilities. For second bit there are 10 options. For third digit there are 10 possibilities. So for the number of license plates having sequence of 3 uppercase alphabets followed by 3 digits will be 26 into 26 into 26 into 10 into 10 into 10. So we will get 17,576,000. So how these number of different possible license plates are possible with the combination of 3 alphabets followed by 3 digits. This is also another example for product rule. Next, one more example. Here a new company with just 2 employees, Sanchez and Patel, rents a floor of building with 12 offices. So how many ways are there to assign different offices to these 2 employees? So here we are having 2 employees, Sanchez and Patel. and here we are having a floor of building with 12 offices. So what you have to compute, how many ways are there to assign different offices to these two employees. For example, see the first person, Sanchez. So out of 12 offices, he can be given any office. So for Sanchez, there are 12 possibilities are there. For the remaining person, the office allotted to Patel must be different from Sanchez. If he is assigned with 1, Patel will have 11 possibilities. So there will be total 12 into 11. These number of all equal to 132. So in 132 ways, we can assign 12 offices differently to these both employees, Sanchez and Patel. So for the first person, there are 12 options that offices can be assigned differently. For the second person, except the office which is allocated to first person, remaining 11 can be assigned to second person. That's why there are 12 into 11 equal 132 different ways to assign 12 offices differently to these two employees. So this is also another example for product rule. Next, see one more problem. How many functions are there from a set with m elements to a set with n elements? For example, a set is containing m elements, a1, a2, a3 and so on, am. And another set is containing n number of elements, b1, b2, b3 and so on, bn. So what is the problem? How many functions are there from a set with m elements to a set with n elements? For example, see this, a1 can be assigned to b1, or it may be assigned to b1, or it may be assigned to b3. That means the element a1 can be assigned to any of these n elements. So for the first element, there are n ways to be assigned. So for the first bit, there will be n number of ways. See the second element, a2. Similarly, a2 can be assigned to any of these n elements. So for the second element, we have n ways to be assigned to element in second set. So for second one, n. Third one, n. And so on, m ways. That means there will be n power m number of ways to assign a function from one set with m elements to another set with n elements. Product rule can also be to count number of one-to-one functions from one set to another set. Here the problem is given like that. How many one-to-one functions are there from a set with m elements to another set with n elements? For example, a set is containing m elements, a1, a2 and so on, am. Another set is containing n elements, b1, b2 and so on, bn. Here what you have to compute, how many one-to-one functions are there from a set with m elements with a set with n elements. What is one-to-one function? One-to-one function is nothing but injective function. That means distinct elements in codomain should be mapped to distinct elements in codomain. That is the definition of injective function or one-to-one function. So that means if a is not equal to b, then f of a not equal to f of b. So this is the definition of one-to-one function. For example, see here a1. a1 can be assigned to any of these n elements. So for the first element, we have n number of ways. For example, we are assuming a1 is assigned to b1. We know that distinct elements should not map to same element. That's why a2 can map any element in codomain other than this element. So if we exclude this element, there will be n minus 1 elements in the codomain. So for the second element in the domain, there are n minus 1 ways to have mapping. So for the second bit, there will be n minus 1 ways. For example, like this. For third bit, except these two, it can be mapped to any other remaining elements. Remaining elements are n minus 2. In this way, finally, n minus of m plus 1. So n into n minus 1 into n minus 2 and so on, n minus m plus 1 number of ways are there to have one-to-one mappings from a set with m elements to a set with n elements. Similarly, telephone numbering plan. So this is also example for product rule. Here, North American numbering plan, NAAP, specify that a telephone number consisting of 10 digit, consisting of a 3-digit area code, 3-digit office code, and 4-digit station code. There are some restrictions on the digits. X denotes a digit from 0 to 9. N denotes a digit from 2 to 9. Y denotes a digit that can be either 0 or 1. Here we are having two plans. One is old plan and another is new plan. In case of old plan, format will be like this. NYX followed by NNX followed by XXX. In the new plan, it will be NXX followed by NXX followed by XXX. So these are the old plan and new plan for the American numbering plan. So using product rule, we have to compute how many number of distinct telephone numbers are possible under the old plan, under the new plan. So what is the old plan? The number should be in this format. NYX followed by NNX followed by XXX. So this is the old format. For example, see NYX. For this, how many possibilities are there? So what is N? N stands for all the digits from 2 to 9. So how many digits are there? 8. Followed by Y. Y contains, that should be either 0 or 1. That means for Y, we have two options. What is X? X denotes a digit between 0 to 9. That means 10 possibilities are there. See compute. First, for NYX, N denotes digit in between 2 to 9. That's why, that means we have 8 options are there. For Y, we can take either 0 or 1. So for Y, we are having two ways. What about X? X means all the digits in between 0 to 9. That means we have 10 options are there. So for NYX format, we will have 8 into 2 into 10. That equal 160 possibilities are there. See the next format, NXX. NXX means for N, we have 8 options. X means all the digits in between 0 to 9. So for X, we will have 10 options. That's why for NXX format, there will be 8 into 10 into 10. So there will be 800 possibilities are there. Next format, NNX. So for N, we have 8 options. That's why 8 followed by 8. For X, we have 10 options are there. So for the format of NNX, we have 8 into 8 into 10. That equal 640 codes are possible. So for the 4-digit code XXXX, we have 10 into 10 into 10 into 10. So 10,000 different station codes are possible for the format XXXX. So number of old plan telephone numbers, we will get 160 into 640 into 10,000. So these are different number of telephone numbers possible under old plan. Next, we have to compute how many different telephone numbers are possible for new plan. So for this formula is 800 into 800 into 10,000. So these are different number of telephone numbers possible under new plan. So this problem is also under product rule. Next, here we are defining product rule in terms of sets. So if A1, A2 and so on Am are finite number of sets, then number of elements in the Cartesian product of these sets is product of number of elements of each set, like this. So if A1, A2 and so on Am are the different sets with a number of elements, then Cartesian product of A1 cross A2 cross and so on Am equal product. Cartesian product of modulus of A1 dot modulus of A2 dot and so on modulus of Am. So this is nothing but product rule in terms of set. Next we are going to discuss about sum rule. So what is a sum rule? We know that what is product rule? If a procedure is split into two tasks and there are n1 ways to do the first task and there are n2 ways to do the second task, then there will be n1 into n2 number of ways to complete the procedure. Here in terms of sum rule, if a task can be done in either first task or second task but not both. So if a task can be done either in one of n1 ways or in one of n2 ways, where n1 options doesn't match with n2 options, then there will be n1 plus n2 ways to do the task. That means here the procedure can be solved in either n1 ways or n2 ways, and n1 options doesn't have matching with n2 ways. In that option, there will be n1 plus n2 number of ways to complete the given task. So this is called as sum rule. So here example is given. Mathematics department must choose either a student or a faculty member as a representative for a university committee. How many choices are there for this representative? If there are 37 members of mathematics faculty and 83 mathematics majors and no one is both a faculty member and a student. So here mathematics department must choose either one student or one faculty for representing the university committee. So here there are 37 members of the mathematics faculty, 83 members are the students, and no one is both a faculty member and student. So in how many ways we can choose to pick a representative? So from student we have 83 options are there. From faculties, from 37 we can choose one faculty. So total number of ways to choose a representative is 37 plus 83, that equal 120. So in 120 ways we can choose a representative who can be either a student or a faculty but not both. So this is one example for sum rule. Here one more example is given. A student can choose a computer project from one of the three lists. So three lists are given. From the three lists, student has to choose one computer project. So the list contains 23, 15 and 19 possible projects respectively. That means first list contain 23 number of projects, second list contain 15 number of projects, third contain 19 number of projects. Then no project is common to any list. Then how many possible projects are there to choose from? So three lists are given, where first list contains 23, second list contains 15, third list contains 19. So from these three lists, students choose only one project. So here what we have to find, how many possible projects are there to choose from. So from first list there are 23 options. For second list we have 15 options. So for third list we have 19 options. So total 23 plus 15 plus 9. So total 57 ways are there, such that project will be different. So by per sum rule, 23 plus 15 plus 19 equal 57 ways. So there are 57 different ways to choose a project from the given list. Next, we are defining sum rule in terms of sets. So the sum rule can be expressed in terms of sets as cardinality of A union B equal cardinality of A plus cardinality of B. What is cardinality? Number of distinct elements in that set. So sum rule can be expressed in terms of set as cardinality of A union B equal cardinality of A plus cardinality of B. The same rule can also be explained as modulus cardinality of A1 union A2 and so on union AM equal cardinality of A1 plus cardinality of A2 plus and so on cardinality of AM, where AI intersection AJ equal to empty. That means each set doesn't have any common element. So cardinality of A1 union A2 and so on union AM, where all are different, is cardinality of A1 plus cardinality of A2 plus and so on cardinality of AM. This is sum rule in terms of sets. Sometimes we have to combine both sum rule and product rule. Here one example is given. Suppose statement label in a programming language can be either a single letter or a letter followed by digit. Here we are having two tasks, either a letter or this one. So that means here we have to apply sum rule. For this, a letter followed by digit means here two tasks. It is in product rule. So here we have to apply sum rule and product rule. What is single letter? For single letter can be chosen in 26 ways, because we know that in English alphabet we have only 26 letters are there. So a single letter can be chosen in 26 ways. Plus or what is the second option? A letter followed by digit. Letter means we have 26 option followed by digit. Digit can be between 0 to 9. That means for having digit we have 10 options are there. So for a letter followed by digit we have 26 into 10. So total 286 possibilities are there for having a single letter or a letter followed by a digit. Here we are combining both sum rule and product rule. Next, counting password. Here one problem is given. Each user on a computer system has a password which is 6 to 8 digit long. That means password may be 6 digit or 7 digit or 8 digit. So we can apply here sum rule. It may be 6 digit or it may be 7 digit or it may be 8 digit. We have to compute this P6 or P7 or P8, where each character is uppercase or a digit. So each password must contain at least 1 digit. Here some condition is given. Password should be minimum 6 character or 7 character or 8 character, and every character can be either uppercase letter or digit. And we have to note that every password must contain at least 1 digit. Satisfying all this condition, we have to find how many passwords are there. See this, here we have to find number of passwords of length 6 or 7 or 8. That's why here we have to apply sum rule. That's why P equal P6 plus P7 plus P8. Next we have to find P6, P7, P8. What is P6? Password having length 6. For example, 6 words. Password having 6 length. So first letter may be either alphabet or digit. For alphabet we have 26 options. For digit we have 10 options. So for first bit we have 36 options. because it may be either alphabet or it may be digit. For alphabet, we have 26 options. For digit, we have 10 options. So for first bit, we have 36 options. So similarly, remaining also. See the second letter. It may be either alphabet or it may be digit. So here this also 26. Like that. So 36 into 36 into total, 36 power 6. In this, we are having all combinations. It may be letter or it may be digit. For the given condition is, the password must contain at least one digit. Digit means, that's why we are subtracting this. 36 power 6 minus 26 power 6. That means, from all the combinations of passwords of letters and digits, we are subtracting the combination of alphabets. Then we will get passwords which having at least one digit. So if we subtract this, we will get this value. That means these are the possible number of passwords which length 6 and which contains at least one digit. Similarly, P7. P7 contains passwords of length 7. So as usual, 36 power 7 minus 26 power 7. We will get this value. Similarly, P8. So P6, P7, P8. If we add all these things, then all these are the possible number of passwords which are having length either 6 or 7 or 8. So for this counting password problem, here we are applying sum rule. Next, we are discussing about subtraction rule. So here, if a task can be done in either n1 ways or n2 ways, then the number of ways to do the task is n1 plus n2 minus the number of ways to do the task that are common to two different ways. So this rule is called a subtraction rule. So if a procedure can be done in either n1 ways or n2 ways, then the number of ways to do the task will be n1 plus n2 minus the total number of ways which are common to both n1 and n2. That is nothing but subtraction rule. So this subtraction rule is also called as principle of inclusion and exclusion. So this principle of inclusion and exclusion will be used to find counting bit strings. See the first problem. How many bit strings of length 8 either start with 1 bit or end with 2 consecutive zeros? So we have to find number of bit strings which starts with either 1 or it must end with 2 consecutive zeros. And the bit string length should be 8. So for this, we can apply subtraction rule. First, we will find number of bit strings that start with 1. What is the condition to be satisfied? The bit string length should be 8. So first we are finding number of bit strings that are starting with 1. So first bit no option. Second bit can be either 0 or 1. For this 0 or 1. So we have 7 options here. So in here 8 bit strings, first bit is fixed, it is 1. Second bit can be either 0 or 1. So for second bit we have 2 options. For third bit it can be 0 or 1. So 2 options, 2, 2, 2, 2, 2. So 1 into 2 power 6, 2 power 7. So there are 128 possible strings that are having length 8 and which is starting with 1. Next, we have to compute number of bit strings that are ending with 2 consecutive zeros. That means last 2 values should be 2 zeros. Remaining 6 can be anything. So here we are finding number of bit strings having length 8 and we are ending with 2 consecutive zeros. Here both are fixed. First bit can be either 2, either 1 or 0. So first bit we have 2 options. second bit also can be either 0 or 1. So for this also we have two options, third, fourth, fifth, sixth. So here 2 power 6 options are there. This is fixed. So we have 2 power 6. So 64 possible strings are there that are ending with 2 consecutive zeros. So what is 128? 128 contains that are starting with 1 and which may or which may not end with 2 consecutive zeros. Here 64 denote the number of strings that are ending with 2 consecutive zeros. Next, what you have to find? The string which start with 1 and end with 2 consecutive zeros. So that means string will start with 1, will end with 2 consecutive zeros. So in between we have 5 bits. For each bit we will have 2 options. So there will be 2 power 5 number of possibilities that are starting with 1 and that are ending with 2 consecutive zeros. What we have to compute? We have to compute number of bit strings which start with 1 or end with consecutive zeros. That's why here we have to apply subtraction rule. So we will get 128 plus 64 minus 32. What does 32 indicates here? The number of bit strings that are starting with 1 and ending with 2 zeros. If we subtract this, we will get 160. So what is this 160? There are 160 possible bit strings of length 8 which may either start with 1 or end with 2 consecutive zeros, but not both. So this is example for subtraction rule. So next, subtraction rule in terms of sets. So if A1 and A2 are 2 sets and there are mod A1 ways to select an element from A1 and mod A2 ways to select an element from A2, then number of ways to select element from their union is sum of the number of ways to select element from A1 and number of ways to select element from A2 minus the number of ways to select element from both A1 and A2. So in terms of sets, subtraction rule can be defined as modulus of A1 union A2 equals mod A1 plus mod A2 minus mod A1 intersection A2. So this is nothing but subtraction rule in terms of sets. Next we will discuss about division rule. So what is a division rule? So there are n by d ways to do a task if it can be done a procedure that can be carried out in n ways and for every w exactly d of n ways corresponding to way w. So this is division rule. Now some practice problems are there. So there are 18 mathematics majors and 325 computer science majors at a college. So in how many ways can 2 representatives be picked so that one is a mathematics major and other is a computer science major? So here we are having 18 mathematics major and 325 computer science majors. We have to compute 2 representatives from these majors such that one is from mathematics and another is from computer science. So total is first one person can be chosen from mathematics in 18 ways and second person can be chosen from computers in 325 ways. So there will be total 18 into 325 that equal in 5850. So in 5850 ways we can choose 2 representatives such that one is from mathematics major and second one is from computer science major. So this is an example for product rule. Next one, in how many ways one representative can be picked who is either a mathematics major or a computer science major? That means we have to choose one representative from the class such that the student can be either mathematics major or computer science major. That means here we have to apply sum rule. So one representative can be chosen in 18 ways. And one can be represented from computers in 325 ways. So there will be 18 plus 325. So there will be 343 number of ways to choose one major such that he will be either mathematics major or computer science major. Here multiple choice test is there. So a multiple choice test question contains 10 questions and there are 4 possible options for each question. So see the first bit. In how many ways can a student answer the questions on the test if the student answer every question? So here test containing 10 questions. For each question the student is having 4 possibilities. See the first one. In how many ways a student can answer the question on the test if the student contains every question. So for the first question, how many options are there? 4. So for first question, there are 4 ways to answer that question. For second bit, there are 4 options. So for second question also, we have 4 ways. Similarly, 10th question. So 4 into 4 into 10 times. So there will be 4 power 10 number of ways to answer a question where the test is containing 10 questions and each question is having 4 options. That means here we are applying product rule. See the second bit. In how many ways can a student answer the questions on the test if the student can leave answer blank also? So in the test we are having 10 questions where each question is having 4 options. So student can choose answer from 4 in 4 ways. One more option given is he can leave the answer blank. That means for each question he is having 5 options. For the first 4 he can choose any solution and last option is he can choose the blank. So if you choose the first question there will be 5 options. He can choose any of 4 options or he can left it blank. So first question 5 options. Second question 5. Similarly last one. So there will be 5 power 10 number of ways to choose the answer or he can leave the blank. So this is also another example for product rule. So here now we will discuss about PeasWhole principle. So first see one example. If there are 10 pigeons in a set of 9 pigeonholes, here if you observe we are having 9 pigeonholes. Out of 9 pigeonholes, 10 pigeons have to be accommodated. So if you observe there is at least one pigeonhole where 2 pigeons are accommodated. So if number of pigeons are more than number of pigeonholes, then there will be at least one pigeonhole which contains at least 2 pigeons. Here we are having 9 pigeonholes. We are having 10 pigeons. So 10 pigeons have to be accommodated in 9 pigeonholes such that there will be at least one pigeonhole which contains at least 2 pigeons. So this is called as PeasWhole principle. So this is a statement. If k is a positive integer and k plus 1 objects are to be placed into k boxes, then there is at least one box containing 2 or more objects. So this is the PeasWhole principle. See one example. Suppose there is a group of 367 people. So among a group of 367 people, there will be at least 2 persons which are having same birthday, because we know that day will be 365. So in case of leap year, 366. So even in case of 366 leap year, there will be at least one more person which are having birthday with any person. So according to PeasWhole principle, for the 367 group people, there will be at least 2 people which is having same birthday, even if everyone is having different birthday. One more example, if you take a group of 27 English words, there will be at least 2 words that begin with same alphabet, because we know that English alphabets are 26. So even if we choose 26 letters different, starting with a different alphabet, 27th must match with any of the 26. So out of 27 English words, there will be at least 2 words that begin with same letter. So all these are examples for PeasWhole principle. Next, generalized PeasWhole principle. So if n objects are placed into k boxes, then there is at least one box containing at least floor function of n by k objects. So this is the generalized PeasWhole principle. If n objects are to be kept in k boxes, then there will be at least one box containing at least n by k number of objects. So this is generalized PeasWhole principle. Here one example. If there are 100 group of people, there will be 100 by 12, that equal to 9, who were born in same month. So if out of the 100 people, if we want to find number of persons having born in same month, then we can compute 100 by 12, which is 9. So this is an example for generalized PeasWhole principle. So with this, second unit is completed. Thank you.